How does sensory feedback influence motor pathways? Imagine trying to catch a ball without looking or walking on uneven ground without noticing. Your body constantly receives signals that help you move smoothly. That's where sensory feedback comes into play. It's like your body's way of keeping tabs on what's happening inside and outside. This feedback is essential for controlling how you move and stay balanced. Inside your muscles and joints are special sensors called proprioceptors. These tiny sensors detect how stretched or tense your muscles are and where your joints are positioned. When you stretch your arm or bend your knee, these sensors send signals through sensory nerves to your spinal cord and brain. This information helps your nervous system understand exactly what your body is doing at any moment. For example, muscle spindles are a type of proprioceptor that sense when a muscle is stretched. They send signals to the spinal cord, which then helps regulate muscle contraction. This process is part of reflexes, like pulling your hand away from something hot. When you touch something painful, sensory neurons detect the pain and send signals to your spinal cord. Then, motor neurons tell your muscles to contract and pull away quickly. This reflex happens automatically and helps protect your body from harm. Your brain also uses sensory feedback to plan and adjust movements. The main pathway for voluntary movements is called the corticospinal tract. It carries commands from your brain's motor cortex down to your spinal cord and muscles. But sensory feedback influences these motor pathways by filtering out unnecessary signals. It helps your brain focus on important information, like unexpected obstacles or sudden changes. This filtering process is called gating and makes your movements more precise. During movement, your nervous system uses a process called alpha-gamma coactivation. When your brain sends signals to contract your muscles, it also activates gamma motor neurons. These gamma neurons tighten the muscle spindles, keeping them sensitive to stretch even when your muscles are contracting. This continuous feedback allows for fine-tuned control of your movements. In addition, sensory feedback is vital for reflexes. For instance, the flexor reflex pulls a limb away from a painful stimulus. Sensory neurons detect the pain, activate motor neurons that cause the flexor muscles to contract, and inhibit the extensor muscles. This coordinated response helps you quickly move away from danger. Overall, sensory feedback influences motor pathways by providing ongoing information about muscle length, tension, and joint position. It helps your nervous system adjust movements in real time, whether you are walking, reaching, or balancing. It also filters out predictable signals from your own movements, so your brain can focus on unexpected or important stimuli. This constant exchange between sensory input and motor output keeps your movements smooth, coordinated, and adaptable. Without it, everyday activities would become clumsy and difficult to control.